My name is Nels, and yeah, I'm really happy to be here. I also do understand that I'm like the last thing between you and the end of the day and whatever activity that might involve. But I have some pretty cool stuff to talk about today. I work for Sonos. Can I have a raise of hands to see how many people have heard of Sonos? How many people own Sonos? Right. Sonos is expensive. I'll admit that. But what's that? Yeah, I wish I had that kind of money. We actually get a lot of cool free perks for working at Sonos, so we might talk about that at the end. But yeah, I work for Sonos, and Sonos is based out of Santa Barbara, and for those of you not familiar, that is a couple hours north of here on a coastal beach town. My role is DevOps engineer, and I've been working for Sonos for exactly 1 year. And you can tell when you walk in my home that I've been there for a year because I have a complimentary sound system to prove it. I am involved with the development of infrastructure for Sonos Web Services. And when I'm not herding servers, I'm herding children. The boys were very excited about the idea of Puppet Camp today, but unfortunately they were unable to attend. So what is Sonos? Sonos is a leader in wireless home audio. Sonos, yeah, let's look at those beautiful speakers. They're worth every penny. With Sonos, your entire home can be humming on the same tune, or the same song, or every individual speaker can be playing its own tune. So we actually have a really cool Super Bowl commercial, and this is like just a photo describing that. But yeah, you can be playing all sorts of weird stuff in your house if you can kind of keep track of it in your head. Sonos is not only decent audio hardware, but it's a simple way to synchronize, organize, and stream music. And here are a couple of screenshots of our controllers. We have our iOS controller and our iPad controller, and we also have Android controllers and other stuff, Windows even. Let's see, Sonos speakers, they connect to a variety of music services such as Pandora, Spotify, Amazon Cloud Player, Rhapsody, SiriusXM, Mog, Slacker, and TuneIn Radio, just to name a few. And we're growing. We're not only hiring as fast as we can, but in the past few years, we've seen more growth each year than in the previous 7. Given the fact that Sonos is playing in over 2 million households, our production systems run at about 500,000 requests a minute. So if you do the math on that, it's close to 1 billion requests a day, just from our customer speakers and controller. And I'm only working in one part of the company, so I have no idea what our website gets. And we have a lot of other stuff going on too. So these are just the systems that I try and watch over. But despite our amazing technology, we have had our share of bumps and bruises over the years, got our share of problems. The initial web service release process was incredibly manual. Generally, it starts in a chat. We create an instance using the AWS dashboard, we SSH in the box, run some janky script, and then we run a test against the box, and then take a look at the server health, log into the AWS dashboard again, and push it into a load balancer, and pray that nothing breaks. I'm sure that experience hasn't happened to anybody else in this group before, but as system administrators, such experiences to build camaraderie. Yes, I do admit, in the past, Sonos has had its share of issues. We had a lot of people making untracked configuration changes to production servers. And let's face it, that's not exactly ideal. So our solution is Puppet, and automating all the things. So when we started looking into Puppet, we were amazed at how many different components there were, how many features there were. Puppet is pretty substantial, especially if you're looking at the Enterprise Edition. And we were looking at all the knobs and stuff to turn to just get things working. And as I was doing that, I stumbled across a website claiming that there was an easier way to use Puppet. And since I was fairly new, I decided to take the easy way. Initially, this decision was made out of sheer desperation, but eventually we realized this was a fairly normal way to use Puppet. In fact, there are a lot of companies that use Puppet in a completely masterless way. There are a large number of tools that let you use Puppet strictly as a DSL to describe server configurations. And this is just a handful. That people at Yelp, a lot of people that leverage Puppet to make AMIs. They're using Puppet Apply. So yeah, some good company. When Puppet was initially created, it was built in the context of server technology when infrastructure was fairly static, and adding servers was a relatively manual process. But today we live in a different world, and Puppet is still extremely useful. But in some cases, the Puppet Master becomes more of a hassle for reliability than a benefit to the great goal of continuous deployment. But as a side note, Puppet Enterprise has come a really long way at making itself cloud compatible. And it really does an awesome job at managing simple virtual infrastructure. This is a screenshot of the Puppet Apply man page, or the website on Puppet. After our research, we decided that using Puppet Apply could not only enable us to deploy our infrastructure faster, but it also gave us greater flexibility in the way that we used it. We discovered that creating our own tools around Puppet Apply wasn't too difficult. Today, we're going to discuss some of the ways that Sonos uses Puppet Apply not only to configure servers, but also to do slightly more complex tasks, such as creating daemons that run Puppet Apply themselves. Okay. Since the Sonos Music API is built entirely on Amazon Web Services, that will be our infrastructure context. For those of you that have used Amazon Web Services, you can take a little nap right now. We're just going to discuss a little bit of vocabulary before we go down the AWS rabbit hole. Directly from Amazon's website, Amazon Simple Storage Service, or S3, provides developers and IT teams with secure, durable, highly scalable object storage. Amazon S3 is easy to use with a simple web services interface to store and retrieve any amount of data from anywhere on the web. With Amazon S3, you only pay for what you use. So, it's a simple place to drop your files. Some people use it as a database. At Sonos, we use it to store our deployment artifacts and credentials. Artifacts like jar and gem files, credentials like database passwords, and even SSH keys. One other thing I want to point out is AWS IAM, also known as Amazon Web Services Identity and Access Management. This is a web service that enables AWS customers to manage users and user permissions in AWS. Services targeted at organizations with multiple users or systems that use AWS products such as EC2, RDS, or the Management Console. At Sonos, we use IAM for a few things. Developer and operator console, API access, grouping of access policies, instance access to AWS resources, using IAM roles. So, did you know that your instances in EC2 can have the authority to take down all of the other instances in EC2? That's a possibility. So let's go in. We won't do anything too dangerous today. We're going to go and create ourselves an IAM role for an instance, just to wrap our heads around the idea. Okay, we're going to create it, we'll call it demo server. You notice I'm in the test account, right? That's a good thing to do. Separate your production and test resources. What we're going to do is we're going to create a role that gives access to EC2, which is an instance or a server. And I've already created a policy here. And just recently, Amazon has upgraded the IAM policy to like a full-fledged object that you can reference again and again. So that's handy. Okay, so now that we have our demo server, let's take a look at that. And we'll take a look at the policy that I just referenced. So basically, this is JSON, so sorry about that. Basically what's happening here is we are allowing the ability to list this bucket and get objects from the instance role that we've created. And we are going to access this bucket. It's called demo creds. So let's start our instance. And this is, oh, yeah. Everybody see that? Okay. Basically, what this will do is just create us that server. There are a lot of tools that will do this for you. Sonos has created its own tool to do this. We'll just talk about that at a later time. Well, let's look at the S3 bucket, demo creds. This is actually something that we'll be using later on. And here, it's really simple to navigate. It's kind of like a file browser, right? So these are the names of my sisters, Amy, Eliza, Emily, and Kate. That was an interesting childhood. They all love me here.
Older or younger?
They're all my older sisters. Yeah, they're excellent if you're watching, which I doubt any of them are. Let's see. So these are actually public keys, and we'll use these later. So right now, let's see, our server launches. Okay, cool. So what I'm going to do is I'm going to hop onto that instance. Okay, so now that we have our role in place, what we're going to do is we're going to look at another module that we created that will leverage S3 and use it for syncing SSH keys. Anybody do that right now? Use SSH to access their instances? It's default in EC2, so you probably are if you're using AWS. This is just something I uploaded today, so it's not on the Forge, but yeah, it's just going to serve us demonstration purposes. Okay, here we go. All right, now we can do equal stuff. Okay. Oh, I don't want you to see that one. Yeah, you're not supposed to see that. So what we'll do is we'll clone this this Git repository, and then we're going to create ourselves a manifest file, and that manifest file is going to reference the module that we just pulled in, and I'm going to type it very quickly. So basically what this module does is you supply it with a bucket name, a region, path to your SSH keys, and a place to install itself. And from there, it should just work. Famous last words, right? Okay, so we'll do a puppet apply. And in this puppet apply, we are specifying the manifest file, and we're also specifying where the modules are, which in this case is root. And so what you're looking at right now is it's just creating the files that are necessary. And what we're waiting on is the actual synchronization. All of my sister's keys have to get plugged in so that they can hop on my really awesome server. And while we're waiting for that, actually, normally it doesn't take this long, but let's see, we will look at some Ruby code. And this is what actually does the synchronization. This part right in here, you'll notice that it's kind of it's an ERB syntax. Actually, let's start with Puppet, since this is where a lot of us are already familiar. Just adding some files, creating directory, and running sync users. What the nice thing about using templates is you can reference the variables in here. So that's what I'm doing. And for those of you familiar with Ruby, right here we have a handful of static variables, and these variables are going to be key when we execute this daemon. And essentially what it's doing is it's pulling in those public keys, and it is calling the ones that are in the bucket to find users, and it's calling the ones that are matching the group admin. We're marking those as current users. So if we get our defined users minus our current users, we get new users that need to be created. So let's see if we've got some created. Well, we didn't actually see it happen, but I can look at the log. Okay, so what's happened in here is just a handful of Puppet declarations that are taking place. In fact, let me show you this. This is the cron tab that will get run every 5 minutes just to make sure that we're keeping our users in sync. And right now, they're in sync. So what we just kind of diving back into this, what we're doing here is for each user that we notice that is new, we will download the public key for that user, and then we will leverage a user template. Here's the template file right here. So we're actually using the simplicity of Puppet to create these users. And what's nice about it is when, if you want to change, let's say the group, you can simply hard code it in here if you want, or you can update it in the Ruby script right here. So for user group, we're just hard coding that to admin right now. But yeah, this is pretty simple stuff. But the reason why it's nice to be able to leverage Puppet for this is because then you can be getting a nice output for every transaction. You can get good logging, and sometimes when you're running this directly, you don't get to see all the feedback that you want. So this is something that you can do. It might seem a little bit crazy, but it's functional. And so you could actually do this tokenizing. Right now, I'm tokenizing all the file or all of the things that look like variables in here, and I'm replacing those with the user information that I'm pulling in from S3. So it's pretty simple. So like, I will actually create a user for myself. Here's my desktop. And so let's take a look at the desktop. I've got two files. I've got nels.pem and nels.pem.pub. So let's bring nels.pem.pub to nels.pub. And this is actually going to be the basis of the user that gets created. So the user is going to be called nels, and the public key is going to be the contents of this file. So then we will go into S3, and we'll upload. And in fact, right now, I'll try and SSH into that machine using this key. And it shouldn't work because it's not synchronized. In fact, let's take a look at the current users. We look in the admin group. All we've got is Amy, Eliza, Emily, and Kate. And none of those are me. So we will try and log in. That should fail. While we're waiting for that to fail, I'll upload a new key. Also pub. And it's important to upload the public key because you don't want to upload the private key. It's not necessary.
We should consider that an understatement, correct?
Let's see what we got here. I think AWS having to log me out, which is okay. Or I thought I needed to log me out. Okay. All right. From here, we'll upload nels.pub, start the upload, and then as soon as that's done, we can actually, instead of waiting 5 minutes, we will just run this synchronization script. And what it should do is find my user, sync it in, and then we should see me under the admin list, and then I should also be able to log in. Failed last time. Okay, cool. So yeah, that's one example of the stuff that we're doing, but we're really trying to leverage Amazon Web Services as much as we can. If you want to use that, you can just hop on GitHub. All right. Like I mentioned before, we also use S3 to store artifacts. In this case, it's from Ray Jenkins. Sonos has a special Jenkins job for deploying artifacts to test environments. Because of the simplicity of public apply or provisioning framework, happily the provisioner will receive a call which tells it to tear down existing infrastructure like load balancers and autoscaling groups and rebuild. Each server in an autoscaling group then uses Puppet to configure itself and pulls in the necessary artifacts from S3. This is can everybody read that okay, or is that blurry? That's all right, okay. This is a custom Puppet resource we use to get files from S3. If that's all you want to do, this is actually all that's required, as long as you have the AWS CLI installed in advance. We can also do slightly trickier things like pulling the latest artifact data, in this case from a Jenkins build. And yeah, this is actually really useful because then you can get continuous integration in place. And then one other thing that we do is we load credentials, just data blobs from S3 into environment variables or token replacement and configuration files. So an example of this would be, let's say we wanted a password for our MySQL database, then we would store that in S3, and not all of S3 is public. By default, S3 is private, and you can set it up so that only the instances that you want have access to the credentials that they need. And so for this resource, it will optionally take in the, we have kind of like a namespacing that you can say, okay, this is the specific application that we're pulling a credential from, and you have a file name, and then you specify where you want to store it locally, and then it will either plug it into an environment variable, because a lot of times that's a handy place to put it, or it will do a tokenized replacement, like we talked about before. And both of those, I think, cases are very common. Let's see, so what do we gain from Puppet Apply? I think one thing that we get from Puppet Apply is security, and it's not to say that the Puppet Enterprise does not supply a secure solution, but it's nice to know that our instances, they have access to the artifacts and credentials that only they need to know, and the provisioner, or whatever tool that we're using to do this doesn't have to know that information either. So yeah, that's useful. Availability is another topic. Without a single point of failure of a Puppet master, each instance is free to configure itself, whether it's auto-scale or free-range, as I would call it. And this is convenient because our infrastructure is getting increasingly complex. We have a scenario where there are we have to have a multi-regional Cassandra-backed environment that uses SSH tunnels, and there are several auto-scaling groups within each region's deployment, and to top it all, not that that's inherently super complex, but it's not something that a lot of tools can do. So writing our own tool was a good way to solve that problem. But the advantage of having each instance configure itself, it comes in when your instances start creating other instances. And in this application, for every 100 or 300 connections, a completely different instance is created. And so it's going to be very difficult for a Puppet master to keep track of all these changes because they're spawning and getting terminated and auto-scaled on top of that. And so the environment itself is actually kind of confusing to me sometimes. But the Puppet master is not going to be able to keep track of it, and we're not going to, and it's going to be very difficult to auto-sign all of those. So that's why we chose to do things the way that we did. Integrity, I think, is the last point. Our development strategy is AB or blue-green. We only deploy when a change is needed, and despite the fact that we don't have a puppet master distributing changes as they come in, our update process is incredibly succinct. When we perform updates to a deployment and continuous integration, we simply throw away the old deployment. When we deploy to production, we're generally only changing a single redirect entry to update a single service. AD deployments, they've helped us migrate from staging to production effectively with a switch, flip of a switch. And there are cases, however, where patching is needed, and we have the capability of rolling updates by pulling instances in and out of load balancers using the AWS API. Let's see. So, start trying to look at my. Okay, some time for questions. Go ahead.
So you obviously use this for your customer-facing servers. Do you use this for your internal company servers as well, or do you use a Puppet Master?
That's a good question, and we do actually use we use a Puppet Master for our internal servers. There's a different group. I don't work with them, but they're our building tools team, and actually control the server farm that our Jenkins instances run on. And so they use a Puppet Master, and I think it's a perfect situation for it. It seems to work really well. Any other questions?
Not really a question, but I did want to just comment on a couple of the things that you said. There was definitely, well, it's true that if you have one Puppet Master, that could be a single point of failure.
Yeah.
There's almost nobody that runs a single Puppet Master in a large infrastructure. Right?
No, and that's totally true. He brought up the point that that there is. I was mentioning Puppet Master as a single point of failure, but in most cases, people have or companies are using a Puppet Master for every environment potentially, or for a big huge service. Like if they have one particular service, they'll have a Puppet Master for that. Did you have anything?
They even load down.
Yeah. Yeah, exactly. And definitely this is not gospel. This is what we found that works for us. And the people at Puppet, they're way smarter than I am. So I want to make sure that everything I just said was was put into context. Any other thoughts or comments? Go ahead.
So how do you distribute that changes on the service? Because we have applied with modules basically in the service.
Oh, right. So we don't actually manually do that. And something that I brought up, we have a gem that we created that it kind of pairs up the AWS API with the concept of Puppet Apply. And what we do is we use it partially for imaging, and so we'll create an image by using Puppet Apply. And there's also, and we'll also use those images as we are creating our infrastructure. And so we can kind of do it all in one swoop with the tool that we created.
So you just use Puppet Apply one time when you create the machine.
Yeah.
So how do you make sure there is no compromise the
Oh, right. Yeah, we do, and we have testing that we perform on top of that. So we use Ruby. We use Ruby extensively to kind of control the flow of what's happening, but yeah, I can definitely see where you're coming from with Drift on that.
So we use a master as model tool, but we don't call them packages, sign packages, all that. So we apply totally everything like everything after.
Oh yeah, and that's
That's the point of Puppet,
Yeah.
but of course you stay.
exactly. And the thing is, one thing that's possible if, as long as you're kind of freezing your images, you can use the concept of an image as a way to enforce a specific configuration. So if you're passing an image around between your developer environments and your staging environments in production, then you don't have to worry about drift as much. But there are some cases where that does happen, and so that's a really good point.
Anything else? Any other questions, folks?
Okay, one last thing, and this is a shameless plug. Obviously, we need a lot of help at Sonos because we have a lot of growth, and I've been actually doing a lot of this stuff on my own. We need your wisdom. We need your strength. If there's anybody that's interested in getting free hardware, they should definitely apply to Sonos. Okay. All right.
Excellent. Thank you so much.